Hello and welcome. In this breakout session, we'll discuss how several pivotal changes in our industry are driving the Windows ecosystem to broaden its support for more diverse silicon, hardware, and device platforms. We'll also be digging into some of the details behind our exciting announcement that we're working on a comprehensive suite of tools, services, and devices to enable Windows developers to build apps on and for ARM-powered devices just as easily as for traditional PCs. The computing industry landscape has changed beyond all recognition over the last several decades. Important industry-changing moments have been marked by key inflection points, such as the move from vacuum tubes to integrated circuits, the introduction of personal computers and portable computers, and the arrival of the Internet and the World Wide Web. Today, we're seeing several changes in our industry coalescing into an inflection point being driven by a new measure of value for technology. Performance per watt is the new Moore's law. This new measure is being driven by economic and environmental considerations and is having a very real and increasing impact on today's and tomorrow's technologies. For example, the cost of power supply and of cooling are largely governed by the efficiency of the devices and the data centers that run our computing workloads. And how much power is consumed to execute a particular workload will matter even more in the future. But our quest for performance continues unabated. We want our apps to be fast and responsive, to deliver smooth video playback, rapid downloads and streaming, and to deliver liquid smooth visual experiences. Our users want new and innovative, exciting devices in various form factors, at various price points that last for multiple days on a single charge, and are always connected. And Windows users expect their devices to be at the leading edge of these advancements. In fact, Windows has always evolved to support new and exciting silicon innovations. From GPUs that accelerate rendering of graphics and games, to networking and wireless communications silicon built to ensure you're always connected to your data and your services. Today, Windows has perhaps the best support for silicon, peripherals, and devices of any platform. But to ensure that our apps and devices can maximize performance per watt, we need more silicon diversity. More computation engines built and tuned to execute specific workloads, which consume less power for a given amount of work. For example, today we're seeing many exciting new opportunities in areas like AI and ML. And to support these opportunities, we're seeing the emergence of NPUs, neural processing units, silicon built specifically to offload and accelerate the execution of AI workloads, while consuming little power and freeing up the main CPU to do other work. We expect most future computers to include NPUs and other specialized processors tuned for specific computation workloads. NPUs, while relatively new, are built into many modern-day ARM processors, used in several recent smartphones, tablets, and devices like the Surface Pro X. ARM-based systems on a chip, or SoCs, have been used for many decades in almost all forms of embedded device, and almost all modern smart devices such as phones, tablets, TVs, etc. But ARM SoCs are also rapidly becoming viable and exciting in many tablet, laptop, desktop, and even server and cloud scenarios. Microsoft began its journey to support Windows on ARM several years ago. We've been working in partnership with ARM, Qualcomm, and others to ensure that ARM SoC designs support Windows needs and to make sure that Windows can leverage the unique capabilities of ARM-based devices. This work resulted in Windows running on ARM-powered Surface Pro X tablets and on devices from our OEM partners. And as per our recent announcements, ARM cloud services being offered by Azure, starting with Azure Virtual Machines, and ARM containers in Azure Kubernetes services. We've been learning a lot about our efforts to support Windows on ARM. In particular, we learned that Windows users expect their existing Windows applications to run as usual, even on devices using different processors. So, in Windows 10, we built a powerful emulation technology that enables most x86 applications to run on ARM devices. And then in Windows 11, we further improved the emulator to enable Windows to run unmodified x64 apps with even better performance. This emulation capability gives users confidence that their existing apps will continue to run even if they're using an ARM-powered device. But while emulation is a great enabler, we're always striving to improve our targets for improved performance per watt. As has always been the case, for maximum performance, efficiency, and compatibility, most apps will benefit from natively targeting the platforms that they will run on, be that x64 or ARM. Users will often notice when they run native applications, as their applications will feel faster and more responsive. And they'll definitely notice when their portable devices require less frequent charging, which is why we're super excited to announce that we're working to deliver a comprehensive suite of tools, services, and devices to help Windows developers build apps that natively target ARM, just as you build apps for x64 today. Firstly, most of the tools built into Windows itself are now natively targeting ARM. This includes command line tools that are essential to most developers, such as Windows Terminal, PowerShell, and WSL. To demonstrate, here's Kayla.
Thanks, Rich. Hey everyone, I'm Kayla Cinnamon and I'm the Program Manager for Windows Terminal. I'm here to show you the great command line experience on ARM devices. So let's get started. So here's Windows Terminal, a really important tool for many developers. But how do we know it's an ARM native app? Well, first we could take a look at the processor architecture environment variable. And we could do this by typing $env:processor_architecture in PowerShell. So here we can see that the environment says it's ARM64. But just to be sure, let's right-click the Windows button on the taskbar and open Task Manager. Here's the Terminal app. If we right-click Windows Terminal.exe and click Details, we can see that the terminal is in fact an ARM64 process along with most of the other processes running on this device. Windows Terminal has come a long way over the last couple of years. It's even built into Windows 11, but Windows 10 users can still install it from the Microsoft Store. One of the biggest improvements to the terminal is the addition of the Settings UI, which we recently updated to follow the Windows 11 UX, making Terminal feel even more integrated and natural. You can configure Terminal's default profile, PowerShell in this case, and a big improvement in Windows 11 is that you can now configure Windows Terminal as your default terminal emulator here in the startup page of the Settings UI. You can also use the Settings UI to change most of the available terminal-wide settings for each of your profiles. You can even configure things like per-profile background images, control their size, align them to different edges of the pane, and adjust their opacity. This can help you more easily identify one profile from another when you have many tabs or panes open. Now, fans of Linux will be happy to know that their favorite distros also run really great on WSL on Windows on ARM. Let's open an Ubuntu instance. But how do we know this is a real ARM native Ubuntu? Let's install ScreenFetch using the apt package manager by typing sudo apt install ScreenFetch. Once this is installed, we can run ScreenFetch and see what our architecture is for Ubuntu. So here you can see the AR64 indicates that this is indeed a native ARM64 version of Ubuntu. Now, many WSL users also enjoy running Linux GUI apps alongside their Windows apps. Let's run Blender that I installed earlier to save some time. Here you can see an ARM native version of Blender running on an ARM native Linux distro on WSL on Windows on an ARM device, smoothly integrated with the Windows environment. And you can even see here in the taskbar we have Tux overlaid on the Blender icon to show you that this is running in WSL. So there you have it. That's Windows Terminal and WSL running natively on ARM64 to improve your command line experience here on Windows. We're actively working in this space to bring along other open source projects to support ARM64. So make sure to stay tuned for the coming months for news here in this area. Back to you, Rich.
Thanks, Kayla. Great work. So, as you can see from this demo, many of the command line tools developers want and need run just fine on Windows on ARM-powered devices. Now, native command line tools are essential, but so too is a great developer IDE and toolchain, which is why we're really excited to announce an ARM native version of Visual Studio 2022. Yes, the real Visual Studio we all know and love, running natively on ARM. And of course, this ARM native version of Visual Studio will also include ARM native Visual C++ and .NET toolchains. So you can build, debug, run, and test all your native and .NET projects on and for your ARM devices. In fact, .NET 6 already supports ARM, as will .NET 7 that will GA later this year. And we're working to ensure that .NET Framework 4.8.2 will natively target ARM as well. This will enable developers of classic WinForms and WPF applications to natively target ARM-powered devices too. Let's take a look at the new ARM native Visual Studio in action. Here's Windows 11 running on an ARM device. Earlier, I installed the new ARM native version of Visual Studio 2022 and pinned it to the taskbar. Let's launch it. And here we are at the new Visual Studio launching page. Let's create a new project. We'll create a Windows Desktop Wizard project, and we'll call it Another Console App. We'll use the console application template, and in just a few seconds, Visual Studio will open with the source code for our project. Great. Let's change Hello World to Hello Build. Now, just to prove that Visual Studio is running as a real ARM64 application, let's open Task Manager. We'll expand Visual Studio and right-click the project instance and go to Details. Here we can see devenv.exe, which is the Visual Studio process, is actually running as ARM64. Great. Now, let's go back to Visual Studio and set a breakpoint on this app and debug. Visual Studio will rebuild this project and launch it under the debugger. And here we are at the breakpoint we set earlier. Now let's take a look at this application's architecture under Task Manager. We'll open the Details pane and find Another Console App. And then we can see that its process architecture says x64. Wait, that's odd. We were expecting ARM64. If we return to Visual Studio and look at the assembly for this code, we can see that it is actually x64 assembly. What's going on? Let's stop debugging. Oh, look up here. We can see the project is targeting x64, not ARM64. Why is that? Well, this is an early build of the new ARM64 native version of Visual Studio 2022, and we don't yet default native C++ projects to target ARM. That will be fixed in a later build. But what this has allowed us to demonstrate is Windows 11's amazing emulation technology that allows x64 binaries to run on an ARM device, and the new ARM native Visual Studio, debugging an x64 process that's running emulated on an ARM64 device. Awesome. But how do we build an ARM native version of this app? Well, all we have to do is to add a new target to the project's configuration. To do that, we just open up Configuration Manager. We add a new solution platform. We specify ARM64, and we copy the settings from x64. Now we can see the project is targeting ARM64 correctly, and we can launch it under the debugger again. After rebuilding the app, we can see when we hit the breakpoint that we're looking at ARM assembly code with ARM registers and instructions. And if we look at the application under Task Manager once more, under the Details pane, we can find Another Console App, and we can see that it is correctly targeting ARM64. Great. Now let's go back to the app and let it run to completion. And we can see that it emitted Hello Build, as we expected. This was just a quick demo of Visual Studio running natively on an ARM device, building, debugging, and running an app that targets both x64 and ARM. And as you saw, Visual Studio on ARM looks and feels just like Visual Studio does on a traditional x64 PC. This is deliberate. Building Windows apps that target ARM should not be difficult, and should have the same efficient code, build, debug, and test and packaging experiences, regardless of whether you're building apps for x64 or ARM. The new ARM native version of Visual Studio is well on its way to its first preview release in just a few weeks, and will be improving rapidly over the coming months on its way to GA by the end of the calendar year. We can't wait to hear your feedback and look forward to working with you to make it as easy to build ARM native Windows apps as it is to build x64 native Windows apps. In addition, we're working closely with several partners and open source projects to help them natively target Windows on ARM. Some projects already support Windows on ARM, including Electron, and thus Microsoft Teams and Visual Studio Code, as does OpenJDK and Java. In the coming months, we aim to see Python, Node, Git, Go, Rust, and many tools, runtimes, libraries, and projects natively supporting Windows on ARM. We also encourage you to get involved too, to support and help your favorite open source projects natively target Windows on ARM. Now, ARM native apps and tools are great, but how do you build and test your code? Many developers employ CI/CD, continual integration, continual deployment techniques and technologies to automate the building and testing of their code. So when you push your code changes up to your repo, a build is triggered, and if successful, your tests are executed. Some go the extra steps. If the tests execute successfully, your app is automatically packaged and published to its download location or even the Microsoft Store. But how do you do this for ARM? Well, the Microsoft Azure team unveiled a preview of their ARM-powered VMs just a few weeks ago and are working toward their GA. If you host your own build infrastructure, you could use ARM Azure VMs to build and test your Windows and Linux code and apps using the ASDO and GitHub Runner agent that will be porting to target ARM later this summer. And for those who prefer to use cloud-hosted CI/CD services, we're also working with Azure and with GitHub to finalize our roadmap for hosting ARM CI/CD services. Further, if you use containers, you'll also be able to build and manage ARM containers via Azure Kubernetes Services, AKS, in the coming months too. And if you would like to test your x64 and your ARM Windows applications automatically and continuously against upcoming Windows releases and updates, you'll be interested to know that TestBase for Microsoft 365 is actively working to support ARM as well. We'll be sharing a lot more details on these plans later in the summer. Again, stay tuned to the Windows Developer blog for news and updates. Great! So we have ARM DevTools, ARM VMs in which you can execute your Windows and Linux workloads, and several cloud-hosted ARM developer services are on the way. But what about the local developer experience? Where will you run your ARM native versions of Visual Studio, Visual C++, and .NET, etc.? Well, today you can run Windows 11 and all the ARM native DevTools on devices like the Surface Pro X or Lenovo's new ThinkPad X13s. These are great ARM-powered devices that can handle most developers' workloads, especially for those that need to work while on the move. But we know many developers would appreciate a device tuned specifically for developers' needs, which is why we're announcing that we're working on Project Volterra, a new ARM-powered device built by Windows developers for Windows developers. Project Volterra has been designed to run all of the tools developers need to build, debug, test, package, and deploy their code, and will be more than able to handle most developers' workloads. In fact, the command line and Visual Studio demos you've just seen will both run on Project Volterra devices. Alas, Project Volterra has been delayed a little by the combination of recent world events, but we will be sharing a lot more details on this device and how to get them later in the summer. Stay tuned. Now, we know that many of you are excited to learn about how an NPU might benefit your AI-powered applications. The currently available Surface Pro X and Lenovo ThinkPad X13s, as well as the upcoming Project Volterra, are great devices to explore Qualcomm's recent NPU silicon. You will also be able to use these and other devices to explore our newly announced prototype AI toolchain in Azure ML, which will provide developers with a growing ecosystem of tools and services running locally on users' devices and at scale in Azure. This is a great time to start exploring how you can leverage AI to deliver exciting new capabilities to your users. So, as we've seen throughout this session, Windows is continuing to evolve to support exciting new opportunities offered by today's and tomorrow's silicon innovations. Our comprehensive suite of platforms, tools, services, and devices offer developers what they need to build apps that natively target both x64 and ARM. And our new Prototype AI toolkit will offer exciting opportunities to leverage the power of AI via local hardware and services in Azure. By the end of the calendar year 2022, most of the developer tools that you rely on to build your apps will be available natively for both x64 and ARM-powered devices, with more to follow in the future. Windows developers now have more opportunity than ever before to build new, exciting and innovative apps and experiences published to the new powerful and flexible Microsoft Store to deliver exceptional value to your customers and users. I hope you'll agree there's never been a better nor more exciting time to be a Windows developer. Stay tuned to the Windows Developer blog for lots more news as these efforts evolve. And thanks for watching. Enjoy the rest of the build session.